video, we'll go through the number line method for absolute value, solving absolute value equations. So the first step for a problem like number 9 would be to add 16 to both sides. Now notice that inside the absolute value bars, 3 and 9 have a common factor of 3. If I reverse distribute that out, then what's going to remain is going to be x plus 3. And that's easy enough for me to verify when I distribute the 3 back through. So I'll make the 3 blue. I've reverse distributed the 3 out. If I multiply this expression by the blue 3, I'm going to get exactly what I have above. So I've factored a 3 out. And then what I can do in a problem like this, when I have shared factors inside the absolute value bars, I can then take the blue 3 and I can move it outside of the absolute value bars, just leaving x plus 3 on the inside. And then I would divide both sides by the blue 3, and I would have this problem. Now, for the number line method, what I would need to do is find the center. So this will be step 1. I need to find the center of my number line. So I'm going to take x plus 3 and set it equal to 0. And I'm going to determine that the center of my number line is negative 3. So then in step 2, I draw my number line. It's centered at negative 3. And then determining my boundary points or solutions, I'm going to travel 7, and I'm getting the 7 right here. I'm going to travel 7 units on either side of my center piece. So this is going to put me at one boundary point of 4. Negative 3 plus 7 is 4. And then my other boundary point is negative 10. Negative 7 plus negative 3 is negative 10. So my two solutions for this particular problem would be negative 10 and positive 4. And I've arrived at those boundary points by analyzing the number line rather than by solving two equations. So let me give you another example that's similar but not quite as easy to see. So let's look at number 11. The first thing I would need to do is divide both sides by the negative 5 in order to isolate the absolute value. So when I do that, I'm going to set this equal to positive 3. So I've got an isolated absolute value expression set equal to a positive number. So I'm clear there. Now when I analyze inside the bars, I see that 6 and 21 share a factor of 3. So if I reverse distribute that 3 out, this is what remains. And I can check it. If I multiply 2x by 3, I get 6x. If I multiply 3 by negative 7, I get negative 21. And I'll make this 3 blue again. So what I can do with the factor, the GCF that I have removed from the expression, I can put it outside the absolute value bar. And then on the way to isolating, I can divide both sides by the 3. And I now have this. 2x minus 7, setting that equal to positive 1. And now to carry on with my number line method, the first thing I'm going to do is find my center. So I take 2x minus 7 and I set it equal to 0. So my first step is going to be to add 7. My next step is to divide by 2. So I draw my number line. My number line centers at 7 over 2. Now this one's a little bit different because in order to figure out how far I travel on either side of my center piece, I'm going to have to travel 1 unit divided by the coefficient on the x term. So that means I'm going to travel 1/2 in the positive direction and 1/2 in the negative direction, comparing that to my center. And when I look at this, I can see that I've got a common denominator in the key pieces, in the key spots. So in order for me to arrive at the first boundary point, I'm going to add 7 over 2 and 1/2. That gives me 8 over 2, gives me a boundary point of 4. And then if I add 7 over 2 to negative 1/2, that gives me a boundary point of 6 over 2, or the integer 3. So my two boundary points, or my two solutions for this problem, would be 3 and 4. And I've arrived at those by a method other than solving two equations. we set up a little model in class, and I will use this, let's see, I'll use this example right here. So the model that we set up in class was like this: ax plus b equaling c. And the problem occurs, or the challenge occurs, when a is not positive 1. When a is positive 1, we're doing exactly the same thing, but we don't notice it because a is positive 1. So to find my center is where I would take ax plus b and set it equal to 0. So my center is going to be the value negative b over a, which is what I would have right here, negative b over a. And then to find my two endpoints, let me erase some of my board here. To find the 2 points to actually solve the problem, the pattern or the formula that we derived in class. So here's my center. And then to get my 2 boundary points, I'm going to take what the absolute value is set equal to. So here are my boundary points. My boundary points are positive c over a and negative c over a. And my center is negative b over a. And that's the example that we talked about in class. But the ability to take a problem and match up what's happening by following the formula, that's an important skill.